So what you're seeing here, and Ms. Matheny pointed this out to you guys, write on your stuff. So you got John looked at the effects of fertilizer on the growth of bean plants. So when you think about it like this, a good title should show you the IV and the DV before you even get into breaking it down. All right? So right here, for 10 grams of this, 10 grams of that, these are both the IV. What did they do at the end of the experiment? What did he do at the end of the experiment? He recorded. This is your DV. Remember, these measurements, at the end, when they record, measure, time, mass, that's all usually the DV, the response to the IV. So this is just the same stuff. And I want to draw your attention to this problem. So IV is the two fertilizers. Height of the plants, you should say of the plants, I'm just abbreviating here. Is there a control shown in this problem?
No.
There's no control shown in this problem. But we can get a control. We can actually not get a control, but we can say what it should have been. How about this? How about do a third plot where we put all the plants set up just like the other ones, and we do, remember, doing the experiment without the IV is what a control is. So there it is, pretty much 0 grams. Now, what about constant? What about your constant?
Amount of water and sunlight each day.
Not the most important one.
Repeated trial? Or no?
Well, you're just yelling out things. Now think about what you're saying. What value did he use for A and B? 10 grams. Now, yes, it does say same amount of water, but the most important constant, is this right here. Let me just switch to the other one. It's the most important one, 10 grams. Now, if he used 20 grams for flat A and 10 for flat B, and flat B grew more plants, or had a greater height, that's bad science. If you're comparing the two, you give them the same quantity of food, or fertilizer in this case. All right? So that's the most important constant, is the one that can become a variable. Does everyone understand? All right. I wanted to do, I'm going to just show you these, and that's 2. I'm not going to elaborate much, so I'm just going to, while we're doing this, I'm going to try and pause while we go along. So let's look at 3. 3 had a control, and let's look at, okay, let's, I like to show this one because, all right, so first, what is Alan doing? He's seeing if magnesium or metals prevent rusting. The beginning of the problem is always reveal the IV and the DV. So the IV, right, is the different types of metals. Here's the DV. All right, now I like to point something out about this one because, all right, there is a control right here. Number one nail by itself. That's your control. Okay, then 2, 3, 4 are all your levels of IV. Those are your levels of IV. I should actually say it like that. All right. Now, one of the things about the DV at the end, this DV is actually complex because this is the DV. But then he also had this. This is the DV. There are all ways of interpreting whether rusting occurred. And he can actually come up with a scale and quantify this by like the color here. You can say, oh well, dark red is in a scale of 1 to 5, and then dark or orange or something like that. So, all right. So let's go ahead and go to one more example. Put that over. All right. So I need to do this. come over to LB Bruin. A reminder, all these solutions are on Blackboard. When you left last class period, I suggested it. So, look, this is good old LB Bruin. She wanted to test the process of osmosis and measure how much water leaves over time. Okay, and then she placed it in a salt solution. So this is all key things here. All right, so she cut 8 pieces. She put all of them in a 25% salt solution, and then she took one out every 10 minutes. And she did that until she got up to 70 minutes. So, what is the independent variable? Time. Okay? Now, I'm going to write time in salt. This is the abbreviation for solution. We use that in chemistry all the time. SONL. You can write the full word. I'm going to abbreviate for time purposes. Okay. What is the DV? What did she measure?
The length of the potato.
Right? At the end, she measured it. This is actually how you're measuring the DV. But actually, we'll accept that, but technically the DV is the water loss. So I'm going to write it twice. You guys know this is the symbol for average, right? Hey, that's the symbol for average. Average, what? What did we say? She did the average length
of the two sides.
I'll just say average length of the potato, okay? And again, we're flexible when we're grading this as a quiz, right? You got some leeway there. All right, now let's do this.
For those of you who didn't do your homework, I'm going to take it out.
Water, that's H2O. No, hydrogen oxide, no. All right, so the water loss is actually the dependent variable. We're measuring it by comparing the average size. Did it get larger or smaller? Okay, constant. The most important constant, yes?
The amount of 25% salt solution.
Exactly. The 25%
in each contained beaker.
Salt, I'm going to write this, SON, solution. All right? What about the control?
She leaves one out.
Okay, so the one left out, I'll accept that. The one left out, or you can say the one not put in the salt solution. Okay. Now, you want to see how you could actually do the same experiment and have the same DV, but you guys realize, well, I could do this. I could say the same time, change that to a constant, and I could do, say, 5% salt solution, 10%, and you have a similar experiment on the effects of salt solution on water loss. All right? And I'm not going to do that, but a hint for future quizzes, like in a couple minutes. So, the only thing I want you to do is look at this now, and then all right, so this is going to go away. Anyone need it still? All right, so what we want to do is you had this handout last class, Rick. I want you to draw your lines in. And so I'm going to write 0 time, right? Because the time was the DV, right? IV. The DV is the water loss. But I want you to draw your columns. So 0, 10 minute, and just to save a little time, I'm just going to draw an arrow and say 70. And you guys, on this line right here, you need to say the number of trials. Go back and look at what LB did. Go back to this and look at what LB did. So she found out that 4 of her friends did it, so 4 plus her, that gives you 5 trials. Does that make sense? That's how you should do this. So really, you kind of list your IV here, the levels, And then, as it says here, you draw a little line. This is an organization chart to help you see how many trials each one is done. And if it's, you should have the same number of trials. Look, the control is there. You light the control first. No time, no exposure to the salt. And then this is level 1 through 7 if you want to be technical. Are there any questions? Yes?
Where does it say that 4 of the students or friends did that?
Okay. I'll show you in a second. Let me just go in. We're pretty much done recording.